Hello everyone, and welcome to the Interim 1 test review for Algebra 1 at Freedom High School. I'm going to go through these fairly quickly just so that this isn't a 1-hour video. At any time, if I go too quickly, remember, you always can rewind because this is YouTube. Okay, so number 1, write an expression that correctly represents m squared more than z tripled. So write an expression that correctly represents 10 more than the product of 7 and c. And write, so these are expressions. This is an equation, so we know we're going to have an equal sign. So the quotient of x cubed and y, because remember quotient means division, is 10. Write an equation that correctly represents the absolute value of the difference of a number cubed and 5 is at most the square root of n. Now, actually, I really should change this here to an x cubed because I'm not 100% sure that this variable and this variable are the same based on the writing in the question. 45. If 45 children sign up to ride a bus and each bus carries X children, write an expression that could be used to determine the number of vehicles we need for the trip. So if we had a bus that carried 10 kids, it'd be 45 divided by 10. If we had a bus that carried 20 kids, it'd be 45 divided by 20. So in this case, it's going to be 45 divided by X would give us the number of buses we need. Number 6, circle all the statements that correctly represent the algebraic expression x cubed minus 4. So a number q subtracted by 4 and 4 less than a number cubed. This is an example of modeling a technology enhanced question. You will see questions like this on the SOL. Whenever you see a question like this, it's generally true that there's going to be more than one answer. Not always, but most of the time there's more than one answer. Just to be clear, the difference of triple a number and 4 is 3x minus 4. And the cube root of a number minus 4 is that. All right, which one of the following is an example of the transitive property? So the transitive property is if A equals B and B equals C, then A equals C. So the one we're looking for here is this one. If X equals Y and Y equals Z minus 4, then X equals Z minus 4. And then you can see the transitive. Circle the equation that does not have the same property as the other equations below. So this is the commutative property of addition. This is the commutative property of multiplication. This is the commutative property of addition. This one, though, is the order didn't change. What's in the parentheses changed, so that's the associative property. So the answer is C. Okay, so now we have to match all of these with the mathematically. So a number plus its opposite equals 0 is the additive identity property. I'm sorry, not the additive identity. I misspoke. I apologize. The additive inverse property, which is G. This, they're distributing the 5. That's the distributive property. Anything times 0 is the multiplication property of 0. Anything times 0 equaling 0. Here they change the parentheses, so that's the associative property of multiplication. Here they reverse the order, so that's the commutative property of addition. On this one, any number of times its reciprocal is 1 is the multiplicative inverse, which is E. Any number of times 1 is itself is the multiplicative identity. Once again here, the order on this one, the order did not change. What's inside the parentheses did. So that's the associative property of addition. For this one, a lot of people get confused by this, but remember the equal sign moves both ways. Right here you can see that this is still the distributive property. Any number plus 0 is itself. So that is the additive identity property. This is the A equals B, then B equals A, which is the symmetric property. Any number equals itself is the reflexive property. And then here we have what the problem we just did, which is the transitive property. Okay, going from here to here, what changed? Now, one way to do these problems is to look at what changed from the one step to the next and set them equally to each other. Sometimes if you write it that way, it's easier to see the property, which is clearly the distributive property. So if 5n equals 10, what property justifies writing the expression below? So what changed was we substituted in. So that is the substitution property. Okay. What is the value of 3p minus 2q over p times q? So this is 3 times 2 minus 2 times negative 7 all over 2 times negative 7. Now the tricky part here is that this is going to be 6 plus 14, because it's minus 2, negative 7, negative times negative is a positive, over negative 14, which is 20 over negative 14, which can be simplified down to negative 10 over 7. All right, what is the value of 2 times the cube root of 27 minus 40, the square root of 48? And the easiest way to do this is probably just type it straight into the calculator, which I can show you how to do here real quick. Because of course. So this is, sorry, you can't, so it's 2 times, you hit math right there, then you arrow over, you arrow down to the cube root of 27, then you arrow out minus the square root of 48. And we will get approximately negative 0.928. In the absence of instructions, let's go to 3 decimal places. Now it also asks, what does this mean? and that is the cube root of x. (14) The area of a triangle can be determined by evaluating the expression 1/2 BH, where B is the base and H is the height of the triangle. What is the area of a triangle with a base of 6 inches, so B equals 6, and a height of 8 inches, so H equals 8. So that's just 1/2 6 inches times 8 inches. And you just multiply that out, and you will get 24 inches squared. Remember, units matter. All right, so these bars here mean that this is an absolute value problem. So we're going to plug in. So this is -2 times 5 minus 7. I'm sorry, 5 minus... Hold on one second. Sorry, I got interrupted by someone coming into the classroom. So let's start this all over. So this is -2 times 7 minus 9. There we go. Plus 5, which is -2 times the absolute value of -2 plus 5. The mistake a lot of people make is they want to change this negative here into a positive. We don't do that. We wait until we get down to a single number, and then we apply the absolute value function. This will be -4 plus 5, which is -1. Once again, it is possible to do this whole problem on the calculator. Let me see if I can bring this over here so we can see it. So what you would do is you would just go -2, and you go math, and if you go over one arrow, there's your absolute value. We would just go 7 minus 9, and then you would put the plus 5 outside the absolute value, hit enter. Oh, sorry, it's +1. Look at me making a mistake. -4 plus 5 is +1. Really shouldn't make these videos late in the evening, should I? I apologize, guys. So the next problem is we're going to plug in again. 5 times j, which is -6, minus 2 times g, which is -5, all over -5 times 6, which is 30 plus 10 over -30, which will give me 40 over -40 over 30, which is -4/3. If you did a decimal equivalent, that'd be -1.3 repeating. For 17, this is going to be 3/4 squared plus 4 times 3/4 minus 5. This will be, if you square a fraction, you square the top and the bottom. This will give you -23 over 16. If you can follow that along, I'd be happy to show that to you, but for most people it's probably going to be easier to do the fraction in the calculator. This is equals -1.4375. 4 is not there. For number 18, this is the square root of 144 plus -3 cubed, which will be 12 minus 27, which is -15. For number 19, this is 3 times the cube root of 64. But all of that is squared, so we have to do what's inside the parentheses first. So that's 3 times 4 squared, or 12 squared, which is 144. For number 20, Now we have new instructions. Sorry, the instructions aren't here, so I'll write it down. So from here on out, the instructions are solve. So I want to get x by itself. So I need to get rid of this -4. So I will add 4 to both sides. And I will get 17 equals -x. Now for most of you, then you would divide both sides by -1. You would get -17 equals x. Now a fun thing is that dividing by -1 is the same as multiplying both sides by -1. You still get the same answer. For 21, once again trying to get the x by itself, so I'll add 8 to both sides, and I'll have x over 2 equals 23. A lot of people get confused here, but this is x divided by 2, so to undo division, we multiply. The 2's cancel, and I'll get x equals 46. For this one, I will need to get rid of the 5, so I'll add 5 to both sides, and I'll get 1/3 x equals 2. And I will multiply by the reciprocal to get rid of the fraction. And now that cancels, and I'll get x equals 6. Once again, if I'm going quickly, feel free to rewind. For number 23, for most of you, what you're going to do is you're going to distribute. So you'll go 2x minus 12 equals -12. Then you add 12 to both sides, and you'll get 2x equals 0. Now, a lot of people think they've made a mistake, but they haven't. The answer is 0. If I plug 0 into that equation, it makes the statement true. 0 is the only number I can plug into that equation to make it true. So it is the correct answer. Once again, write an imaginary 1 in here if it helps, and that'll give you -5x minus x equals 1. Add 5 to both sides, I get -x equals 6. Divide both sides by -1, and I get x equals -6. Once again, we're distributing, but we're distributing a negative, so be careful. This will be -3x plus 9 equals 15. So we're going to subtract 9 from both sides. A lot of people like to write their dotted line down here for both sides of the equation. You get -3x equals 6. Divide both sides by -3, and you get x equals -2. So for this one, I'm going to rewrite it just so we can see. When it's written as a fraction like this, to get rid of the fraction, we're going to multiply both sides by the denominator. And those cancel. I'm left with 5 minus x equals 9. Then I subtract 5 from both sides, and I'll get -x equals 4. Divide both sides by -1, and I'll get x equals -4. Here, we distribute the 1/2 is one way to do this. And I'll get 2x minus 5/2 equals 8. Now that doesn't appeal to a lot of people, so I'm going to show you an alternate way to do this problem, which is, we start off with the problem, and instead of distributing, we're just going to get rid of the fraction by multiplying both sides by 2. Fraction cancels, and I'm left with 4x minus 5 equals 16. Add 5 to both sides, I'll get 4x equals 21. Divide both sides by 4, and I'll get x equals 21 over 4, or 5.25. All right, last problem. Once again, we can use the same trick we did last time, multiplying both sides by 3, getting rid of the fraction. And I'll get 7 minus 5x equals 27. Subtract 7 from both sides, and I'll get negative 5x equals 20. Divide both sides by negative 5, and I'll get x equals negative 4. So hopefully that was enough of an explanation for everybody to get ready for their interim tests. If you have any questions on any of these problems, please bring them to your teacher. It's possible I made a mistake, even though we did go over the key twice. And good luck.